The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, today we're going to go on to section 11.3. But first of all, we had a question. This is from 11.2, number 24. It says the following function is 1-to-1, and that is f of x equals 7x cubed minus 2. It says find the inverse of the function and express it using f inverse of x notation. So step number one, replace f of x with y. Step number two, interchange x and y. Step number three, solve for y. Let's see, I'm going to add 2 to both sides. So that's going to give me x plus 2 equals 7y cubed. Then I'm going to divide both sides by 7. So I get x plus 2 over 7 equals y cubed, which I'm going to rewrite as y cubed equals x plus 2 over 7. Okay. And then I'm going to take the cube root of both sides. Okay. So I get y equals the cube root of the quantity x plus 2 over 7. Okay, so then that would be f inverse of x equals the cube root of, hang on here, x plus 2 over 7. And there you have it. Any questions about that one? Okay, so now, let's see here. We've looked at equations and functions that were linear, like y equals 2x, for instance. Y equals 2x. Well, that would have a slope of 2 and a y-intercept of 0. So it would look like this. Hang on here, let me get this graphed. So there's a linear equation in the form, or just, yeah, anyway, linear equation y equals 2x, okay? We've looked at quadratic or second degree equations in the form of, like, let's say y equals x squared. Where we get a parabola. So we've got linear equations, second degree or quadratic equations. Today we're going to look at exponential equations, and that one of those might look like this: y equals 2 to the x power, where the variable is the exponent. Okay, now to explore that, I'm going to switch screens, so give me just a minute here. Here. All right. Can you now see the graphing board where it says f of x equals 2 to the x, and there's a table and everything?
Yeah.
Okay, super. Just wanted to make sure I got that switch to work. Okay, so as I've mentioned in the past, I believe, whenever I'm looking at a equation or a function that's new, and let's say I don't know anything about it, I just kind of start out with a table going with x values from -3 to +3, see what those points lead to. Do I need to do something more or something less, whatever. But so I'm going to start out with this. So if x is -3, oops, I've got red, I need to change it here. Okay. Not that it really matters, but So f of -3 would be 2 to the -3 power, which is equal to 1 over 2 cubed, or 1 over 8. Are you okay with that? Remember how a base with a negative exponent, 1 over the base with a positive exponent. Okay. If x is -2, f of -2 equals 2 to the -2 power, which is 1 over 2 squared, or 1/4. If x is -1, f of -1 equals 2 to the -1 power, which is 1 over 2 to the 1 power, or 1/2. If x is 0, f of 0 equals 2 to the 0 power. Remember, any base other than 0 itself raised to the 0 power equals 1. So 2 to the 0 power equals 1. Okay. So here, if x is 1, f of 1 is 2 to the 1 power, which is 2. If x is 2, we get 2 to the 2 power, which is 4. And if x is 3, we get 2 to the 3rd power, which is 8. Notice what's happening to the y values. Each time we increase the x value by 1, the y value doubles. And the graph of this thing, let's see here. When x is -3, y is 1/8, which is about there. When x is -2, we're up to maybe 1/4. When x is -1, we're up to 1/2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. And so we get this picture. It kind of looks like half of a parabola, doesn't it? But in fact, it isn't. Notice if we were to say, pick some different values like -4 and -5, 2 to the -4 is 1 over 2 to the 4th is 1/16. 2 to the -5 is 1 over 2 to the 5th, 1 over 32. So what's happening on this end, this thing's getting closer and closer to the x-axis. But going the other direction, this thing is just going to keep shooting up faster and faster. Okay. Any questions about this example?
No, I'm good.
All right. Some things to point out. This has a y-intercept at what? 0, 1. It doesn't have any x-intercepts, because if we kept going, when we kept making x more and more negative, we're going to get 1 over something larger and larger, but 1 over a bazillion is still not 0. It's going to get close to 0, but not 0. So this thing never crosses the x-axis. So again, your y-intercept is at 0, 1. There's no x-intercepts, okay? This is a function. It passes the vertical line test. Oh, it also passes the horizontal line test. It's a 1-to-1 function. And notice it as we go from left to right, as x gets larger, y gets larger as well. We say that it's increasing over its entire domain. All right, let's take a look at another example. So I already have the graph of f of x equals 2 to the x graphed here. Let's look at 3 to the x and what that looks like. When x is -3, g of -3 is 3 to the -3 power, which is 1 over 3 cubed, which is 1 over 27. Okay. If x is -2, g of -2 is 3 to the -2 power, which is 1 over 3 squared, which is 1/9. If x is -1, g of -1 is 3 to the -1 power, which is 1 over 3 to the 1, or 1/3. If x is 0, g of 0 is 3 to the 0 power, which is 1. If x is 1, g to the 1 power is 3 to the 1 power, which is 3. If x is 2, 3 to the 2 power, this is, let's see here. Okay, there we go. If x is 2, g of 2 equals 3 squared, which is 9. And finally, if x is 3, we get 3 cubed, which is 27. Any question about how I calculated those values before we go on? Nope. Okay. When x is -3, y is 1/27. Wow. Well, instead of 1/8, I've got 1/27. So I guess it's slightly below. Then what, at -2, it's at 1/9. It's climbing a little bit better. Than at -1, it's up to 1/3. Oh, at 0, it's at 1 again. 1 is at 3, 2 goes to 9, 3 goes to 27. So, okay. So what do we got? Well, we've got no x-intercepts, y-intercept at 0, 1. It's increasing over its entire domain. Oh, but it's climbing faster, isn't it? Instead of doubling like these values, it's tripling. So it climbs faster. All right. Any questions about that? Oh,
No.
Now, notice what's going on. Let's go back here. Here I took the base from a 2 to a 3, so I increased the base, made it larger. Whoops. And it climbs faster, steeper, right? It triples instead of doubling. Now let's make the base smaller than the 2. Okay. In fact, smaller than 1. It's a half. So let's see what happens here. H of -3 is 1/2 to the -3 power, which is 2 over 1 to the +3 power, which is 2 to the 3rd power, which is 8. When x is -2, h of -2, excuse me, is 1/2 to the -2 power, which is 2 over 1 to the +2 power. 2 squared is 4. When x is -1, h of -1 is 1/2 to the -1 power, which is 2 over 1 to the 1 power, which is 2. When x is 0, h of 0 is 1/2 to the 0 power, which is 1. When x is 1, h of 1 equals 1/2 to the 1 power, which is 1/2. When x is 2, h of 2 equals 1/2 to the 2 power, which is what? 1/4. And then when x is 3, h of 3 is 1/2 cubed, which is 1/8. Oh, look what's happening there. Instead of the values doubling like they did here, they're halving, so to speak, right? 4 is half of 8, 2 is half of 4, 1 is half of 2. Because if we multiply something by a half, we get half of what we had before. So let's see what this graph looks like. -3, 8, -2, 4, -1, 2, 0, 1, 1/2, 2, 1/4, 3 1/8. Well, it still has a y-intercept of 0, 1. It still has no x-intercepts. Oh, but now instead of it increasing over its entire domain, it's decreasing. Okay. Oh, I should have talked about what is the domain and the range. So let's go back for a minute for this one, 2 to the x. The domain would be all real numbers, but the range, so domain would be all real numbers, but the range is what? Greater than 0. What about for this one? The domain's all real numbers and the range is still greater than or equal to 0, isn't it? Okay. Any questions about this example? So backing up for just a minute, when the base was 2 or larger, whatever, it increased, and it increased faster. So basically, if it's bigger than 1, if it's between 0 and 1, it decreases over its entire domain. Well, what about this one? What about if we just make the base 1? What's that going to look like? Well, let's see. G of -3 equals 1 to the -3 power, which is 1 over 1 cubed, which is 1 over 1, which is 1. G to the -2 power is 1 to the -2 power, which is 1 over 1 squared, which is 1 over 1, which is 1. G to the -1 power is 1 to the -1 is 1 over 1 to the 1 is 1 over 1 is 1. G of 0 is 1 to the 0 power, which is 1. What's 1 to the 1? What's 1 squared? What's 1 cubed? So what does that thing look like? Well, it looks like this. That doesn't fit the pattern, does it? So we basically say the base can't equal 1. And we'll come back and summarize this in a little bit. How about here? So again, let's go back. Always going back. Let's see here. If the base is 2, this thing increased. The base was 3, it increased, but even faster. If it was less than 1, it decreased. If it was 1, it didn't fit the pattern. What if it's negative? What if the base is a negative number? Okay. So R of -3 is -2 to the -3 power, which is 1 over -2 to the +3 power, which is 1 over -8 or 1 or -1/8, excuse me. Okay. If x is -2, R of -2 is -2 to the -2 power, which is 1 over -2 to the +2 power, which is 1/4. If x is -1, R of -1 equals -2 to the -1 power, which is 1 over -2 to the 1, which is 1 over -2, which is -1/2. If x is 0, R of 0 is -2 to the 0 power, which is 1. Look what's happening here. The signs are alternating. -3 is at what? Let's see. -3 is at -1/8. That's down here. -2 is up there at 1/4. -1 is at -1/2. Then 1, 0. It's in fact, if you try to graph this on a graphing calculator, it just sits there and spins. That doesn't work. Okay. So the base can't be negative. What have we got here? G of x equals 2 to the x minus 3. We've got 2 to the x here. 2 to the x minus 3. What's that going to look like? Would anybody like to speculate based on what we did with parabolas? What does that constant term out at the right do to the graph? Anybody? Nope. Okay, fine. So if x is -3, g of -3 equals 2 to the -3 minus 3, which is 1 over 2 cubed minus 3, which is 1/8 minus 3. You know what? I'm just going to leave that as 1/8 minus 3 for now. You'll see why in a minute, hopefully. If x is -2, g of -2 equals 2 to the -2 minus 3, which is 1 over 2 squared minus 3, which is 1/4 minus 3. I'm going to leave that as 1/4 minus 3. G to the -1 is 2 to the -1 minus 3, which is 1 over 2 to the 1 minus 3. Oops, minus 3, not equals, which is 1/2 minus 3. G of 0 is 2 to the 0 minus 3, which is 1 minus 3, which is, -2. I'm still going to leave it as 1 minus 3. Look at what's happening. How do these values compare to those values? These values are the same as those, -3. So if the y values are all 3 less, the graph is going to move down 3 units. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, and our graph is going to look like that. So remember, like y equals x squared was at the origin, y equals x squared minus 3 moved down 3 units. So this exponential graph is going to move down 3 units. So the red graph is 3 units below the black graph. Okay. What do you think is going to happen here? Oh. Well, that minus 3, that's part of the exponent. So it's like that whole thing there. Think back to, again, the parabolas. A constant outside, a plus moved it up, a minus moved it down. But what about a number inside? If it was a plus, it moved it in a negative direction, and a minus, it moved it in a positive direction. So this minus 3 inside there, I'll bet it's going to move it to the right 3 units. Let's see if I'm correct. Let's just do this. Let's put the points in. Let's see. This would be what, 6, 8. Let's find when x is 6. G of 6 equals 2 to the 6 minus 3, which is 2 to the 3, which is 8. Oh, look at that. How about x is 5, y should be 4. 5, 4, 5. G of 5 is 2 to the 5 minus 3, which is 2 to the 2, which is 4. See what's happening? So this graph looks exactly like that graph, but it's shifted to the right 3 units. Okay. What about, let's see, what about this? Now, it's important to note, this is not the same as, as this one right here, because this one was -2 the quantity to the x power, so the base was -2. But the one that I'm doing here, the negative sign is not part of the base. So we're going to take 2 to the x and then apply the negative sign. Okay. Well, how is this going to compare to that? Well, if we put this value in and we take 2 to the x power, we're going to get these same values, but then we're going to put a minus sign in front of it. So we're going to get -1/8, -1/4, -1/2, -1, -2, -4, -8. So what's that going to look like? Well, it's going to look like this. Oops, more or less. Lousy graph, my apologies. Okay, so let's summarize what we've got going on here. If we have an equation in the form y equals b to the x, b has to be greater than 0. B cannot equal 1. If b is greater than 1, the graph increases. If b is between 0 and 1, the graph decreases. Okay. We have a y-intercept at 0, 1, and no x-intercepts when it's in this form. Now, if you add or subtract a number out here and you shift it up or down, then yes, you're going to get x-intercepts. Okay. But anyway, any questions about this information? All right. Now, I'm going to get rid of this screen, maybe. And we'll go back to the whiteboard screen. Okay. All right. Give me a second here. We're going to look at a formula that looks like this. A equals P times 1 plus R over K to the KT power. P stands for the principal. That is the amount invested. R stands for the annual, is that right? Annual, yes. Annual interest rate. K stands for the number of compoundings per year, and T stands for time in years. Let's see. And we'll just go ahead and leave that. That's not a hashtag. That long before that, it meant numbers. It's number of compoundings per year and time in years. Okay, so this is the formula to use to find the effect of compound interest. How does compound interest work? You put money in the bank and you leave it there and they pay you interest on it. But then instead of taking that interest and spending it, you leave the interest in the account. So then you start to get interest on the interest and you leave that in there and you keep leaving it in, you get interest on the interest on the interest, and it compounds much quicker than if you just had simple interest where they just pay you a certain amount of interest and then you take it out, the interest out, and then you leave it there another year and you take the interest out. Anyway, we're going to look at some examples of compound interest. Okay. So this problem says an initial, well, first it says compound interest. An initial deposit of $10,000, so P is $10,000, earns 8% interest, so R is 8%, which would be 0.08. Compounded quarterly, so K is 4. If it's compounded once a year, K is 1. Twice a year or semi-annually, K is 2. Quarterly, K is 4. Monthly, K is 12. Daily, K would be what, 365. How much will be in the account after 10 years? So the A, the accumulated amount, is the unknown. So using the formula, A equals P times 1 plus R divided by K to the KT power, let's see what we get. A equals $10,000 times 1 plus 0.08 divided by 4, all to the 4 times 10 power. Now, there's a couple of different ways you can do this. What you don't ever want to do is round off before the very end of the problem. And even then you might not round off depending on the directions. What I could do in this case, I could predetermine 4 times 10 is 40. I could predetermine 0.08 divided by 4 is 0.02 because those are nice numbers. But if they aren't nice numbers, then you end up having to do the whole thing all at once. Okay, I'm going to do the whole thing all at once. So on my calculator, I'm going to put in 10,000. Okay, then a left-hand parentheses, 1 plus 0.08 divided by 4, close parentheses, the little caret or the power key, okay, and then parentheses 4 times 10, close parentheses, equals, and I get this. This is money, so I get 22080.39664. Now, it didn't say anything about rounding off, but because this is money, we would round to the nearest cent. This is the dollars, so this is the 10 cents and the 1 cent. So we go one place to the right, the 6 would round up. So our final amount is $22,080.40. Any questions about that? All right. Let's take a look at another one. This says, how much more interest could $1,000 earn in 5 years, compounded quarterly, if the annual interest rate was 5.5% instead of 5%? Okay, so we've got a couple of scenarios here. The principal in both cases is $1,000. Says how much interest earn in 5 years, so the time is 5 years, compounded quarterly, so K is 4. If the annual interest rate is 5.5% instead of 5%, so first case we'll make it 5%, second case 5.5%. Okay. All right, so using the formula, A equals P times 1 plus R over K to the KT power. This first case, A is 1,000 times the quantity 1 plus 0.05 over 4 raised to the 4 times 5 power. Okay, so 1,000 parentheses 1 plus 0.05 divided by 4, close parentheses, the caret or power key, parentheses 4 times 5, close parentheses. I get 1,282.037232. So to the nearest cent, $1,282.04. Okay. Now over here, A would be 1,000 times 1 plus 0.055 over 4 to the 4 times 5 power. Okay, so 1,000 parentheses 1 plus 0.055 divided by 4, close parentheses, raised to the power, parentheses 4 times 5, close it up, and I get 1314.066502. So 1314.07. But it said how much, let's see, how much more interest. Okay, so I've got to take that minus that. 1314.07 minus 1282.04, and I get $32.03. So what does that say? That says if you've got, you know, 2 options of investing $1,000 for 5 years at compounded quarterly, having an extra 0.5% interest will get you $32.03 more over the same period of time. So the better interest rate, typically the better that you'll do, kind of thing. Okay. Any questions about that particular example? Okay. Another example, it says compound interest. If $1 had been invested on July 4th, 1776, at 5% interest, they always kind of word it weirdly. They say, 5% interest. Technically, it's at a 5% annual interest rate. Compounded annually, so K is just 1. What would it be worth on July 4th, 2076? So from 1776 to 2076, time would be what, 300 years? Okay, so let's see what we get. Since K is 1, I guess I could have just left it out. If I simplified this, I'd have what? 1 times 1.05 to the 300th power, because this 0.05 divided by 1 would be 0.05, plus 1 would be that, and 1 times 300, etc. Okay. And what's 1 times all of that? Basically all of that. So if you take 1.05 to the 300th power, I get 2273996.129. So that's going to be what? $2,273,996.13. Now, you hear stories about somebody finds some old bonds or some kind of certificates in the attic that's 100 years old, and wow, is it going to be worth a fortune? Well, I don't know if the bank's still in business or whatever, but I wouldn't spend too much time looking in your attic. Anyway, all right, any questions about this compound interest formula? All right, now let's say I have the following formula. A equals 500 times 2/3 to the t power, where t stands for time in years and A stands for the amount of grams of a radioactive material. Okay, so T is time in years and A is an amount of a radioactive material. So this formula is a little bit different from that. We've got this extra coefficient out front there, don't we? So let me ask you this. Riddle me this. Hang on, let me see if I can. Okay. At the beginning of time for this problem, so when t equals 0, what does A equal? Can anybody tell me? In other words,
oh, 0?
Careful.
Oh.
What's 2/3 to the 0 power?
Oh, is that 1?
And what's 1 times 500?
500.
So there's your
0
beginning amount. So at the beginning of time, there's 500 of these, 500 grams of this radioactive material. Okay. Now, over time, is this going to increase or decrease? And tell me why.
Would it decrease because the fraction would just keep getting larger and larger, so then the 500 would get smaller and smaller?
Yeah, now when you say the fraction would get larger,
like it would, the powers would increase, so therefore it would get smaller, I guess.
yes, yes.
But the
Okay,
numbers
yeah,
individually would get larger.
yeah. Okay, well, larger numerators and larger denominators, right? Okay, So basically what we've got here is 500 of something that's decreasing over time. You see that? Now let me read you the whole story. It says 500 grams of a radioactive material decays according to the formula, where T is measured in years. So 500 grams decays, but we can see that just by looking at the formula. Find the amount present in 10 years, round to the nearest 1/10 of a gram. So they want us to find, if we wrote this as a function, A of 10. Okay, it says find the amount present in 10 years. So I'm going to do 500 parentheses 2 divided by 3 close parentheses, little power key 10 equals 8.67076495 blah blah blah, and it says round to the nearest 1/10 of a gram. So the 7 would round up 8.7 grams. Okay with that?
Yeah.
All right. Let's look at another example. This is population growth, and the formula P equals 3,745 times 0.93 to the T power. Okay. So at the beginning of time for this problem, what's the population? So at T equals 0, P equals what?
3,745.
Good. You're catching on. Is the population increasing or decreasing?
Increasing?
Why do you think that?
Or it would be decreasing because it's below 1.
There you go. It's decreasing. Now, careful. Here's the Jeopardy bonus question. By what percentage is it decreasing as time? Let's see. For this problem, time is measured in years. So by what percent is it decreasing every year? Careful.
Is it decreasing by 7%?
Excellent. Good job. Because if you're getting 0.93, you're getting 93% of what you had. So you're losing 7%. You win the car and the hotel and the trip and everything. It'll all be mailed to you. It should be arriving any year now. Okay. Hopefully we'll get your address wrong. Right. So we good with this? We got a population here. It's decreasing by 7% over time. And this particular problem says find the population in 6 years, 9 months. 6 years, 9 months. How many years would that be? Careful. 6 point what?
7/5.
Right, because 9/12 is 3/4 or 7/5. So P of 6.75 would be 3745, 0.93 raised to the 6.75 power. And we got 3745 parentheses 0.93 close parentheses power key, this little key here, power key 6.75 2294.62502, and that is, let's see, does it say? It doesn't say, but they round off to the nearest whole person. Okay. As I'm doing these problems, if you're having issues with a calculator, you want me to go slower, explain more things in terms of the calculator, please let me know. Okay. I think one more. What do we got for time? Yeah, we got time for one more. Okay. There's always time for one more. C of T equals 5 times 1 0.034 to the T power. It says computer viruses. Suppose the number of computers infected by the spread of a virus through an email is described by the exponential function. Okay. Yeah. Where T is the number of minutes since the first infected email was opened. Okay. So the initial infection affected how many computers? C of 0. So at the split second it started, how many computers?
5.
5, right. So time in minutes, for each minute that passes, what is the percentage of increase of infected computers? Careful, very careful. You did well the last time.
You lost me on that one.
Okay, hang on. Let's go back to this one. We said that one, the population was decreasing by 7% per year. Where'd you get the 7%? From that,
From
right?
93, yeah.
Okay. This is increasing by what percent per minute?
Oh, would it be, oh no, I was gonna say 103%, but no, I don't know.
How did you get from there to 7%?
100% minus 93%.
So what's the percent of increase per minute? You're so close.
97? No.
No.
Where are we getting the, you threw me off with that 1.034. The 1 throws me off.
Okay. What if it was this? What would happen to that? What if the base is 1? It doesn't change. This would just be 5 no matter what.
Okay.
What's this represent?
The percentage?
That it's going to, is it going to increase or decrease?
Increase.
By how much? By what percent?
By 3.4.
Yay! And then we can all go home. Good job.
Oh gosh.
You see it?
See why I never speak up?
No.
Ugh.
Hey, what do you mean? You got it right.
Now I'm on the recording wrong.
No, you're not. But see, but everybody sees that you wrestled with it and you got it. Whereas the other people, they weren't even willing to try. So good for you. Besides, nobody knows who Galaxy Note 9 is. It's a galaxy far, far away, right?
Hey, that's my actual name.
Okay, well, awkward moment there. All right. Anyway, so for over the weekend, now I'm going to go back and check. Is she really Galaxy 9 or 8 or 9? Over the weekend, section 11.3. I'll be back at 1:15 with an office hour. And otherwise, I'll see you Monday. Have a great weekend. I'm going to go ahead and stop the recording.